Are you designing your own high power rocket? Or maybe you've got a kit from one of those manufacturers that doesn't provide instructions and you want to know how to make an engine mount and how to design this back part of your rocket. That's what I'm going to cover here in this video.
Welcome to Advanced Construction Videos, where we show you how to tackle rocketry, building techniques, and more. On our website, we sell kits, motors, building supplies, and electronics. So come and learn, shop, build, and fly when you visit us at apogeerockets.com.
Hi, I'm Tim Van Milligan from Apogee Components. We often get the question about designing a rocket and how to arrange the components in the back of the rocket, which is normally your most important part. A lot of manufacturers these days create parts and they call it a kit, but they don't give you any instructions on how to put it together. If you want to know how to put things together and you're going to buy a kit, make sure it's an Apogee kit because we always include instructions. But in this video, I want to show you how to design an engine mount in this back part of the rocket, which is most important. So the most important question that we always get that you want answered is, where should those engine mounts go? Now, I've got a number of rockets here to show you some different configurations, but I can't show you everything, so I brought out my computer here and I've designed a simple rocket in CAD so that I can discuss so many different options. So here we have a generic high power rocket, and I'm going to take the body tube here and I'm going to make it invisible so that we can see on the inside and see the centering rings and the motor tube. And the question we get most often is, where should those centering rings be on the engine mount? Ideally, you want them as far apart as possible. And the reason for that is we want to make sure that the motor tube inside is perfectly concentric with the body tube of the rocket. Because if that motor tube is crooked, it's going to cause a vectored thrust and it's going to make your rocket kind of go horizontal instead of straight up. And by putting the rings as far apart as possible, we get a lot more assurance that it's going to be straight. If they're closer together, it's easy to get that motor mount to wobble, especially if the rings are loose. So by spreading them apart, we make sure that they go, everything goes together nice and straight. Now on this one right here, you'll see that the ring is flush with the front end of the tube. Ideally, I want to move that back a little bit. So I'm going to select that ring and I'm going to move it back just a little bit. So it's off the front of the ring. And the reason for that is we want to get a glue fillet on the front part of the ring, because it makes it a lot stronger. You're going to have a glue fillet on the front and on the back side, but we don't want to forget the front. And if the tube is right at the very edge of the ring, it's going to be a lot harder to make it stronger. You'll also see that this rocket has through-the-wall fin mounts, and that's typical on a lot of rockets. Now, if you want the strongest through-the-wall fins, you want to make sure that the tabs are touching the edge of the ring, like this one right here. And ideally, maybe you might want to put another ring here at this end, and that captures it to make sure that these tabs are really locked in tight. Now, it doesn't have to be, so if your rings aren't touching your tabs, it's going to be okay. But if you're looking for maximum strength, try to arrange things so that they are touching. Now this rocket right here has 3 centering rings, and that can actually be a good thing from a construction point of view because it allows you to get inside the tube and make internal fillets. So if I turn this ring off right here and I turn the body tube back on, you can see what I mean. It allows me to get on the inside, so I can glue this motor mount tube in just using those 2 front rings, and I can still get into the back end and then reach down in here and put in glue fillets on everything on the inside, and then come back later and put the aft ring in place to lock everything in and makes everything look pretty. Now, if I did a video on this particular topic, and I'll link it right here so that you can watch it, and I discussed 2 rings versus 3, and if you have 2 rings, how you can also make internal fin fillets. So watch that video. The other thing is on that back centering ring, you might want to have engine retention back here. So this is your standard screw-on engine retainer, which I was showing you here on this rocket. It simply screws on and off. In order to use that, though, you need to allow that back part of the tube to stick out of the rocket a little bit so that you can have some bonding surface area there to make sure you can glue on that ring. Now, if you don't worry, or if you built your rocket, don't worry. We have different options for you. On this one right here, you can see that the ring is very close to the edge of the tube. And in this case, I'm not going to be able to bond on a screw-on engine retainer like I showed you on the last rocket. In this particular case, we're going to have to use a different engine retention. And there's 3 different options for this. So on this rocket right here, we have what is called a flat bottom engine retainer. And let me pull this off right here so I can see what's on the inside. They're kind of wiggly and jiggly. So you can see I got a flat bottom where the back centering ring, the back of the tube, and the back of the motor mount are all flush. In this case, we can take 3 little screws and this aluminum retainer, and it actually has some little holes in it. And you can put the retainer on. And these screws are going to be tightened down a little bit before I do this. I just want to show you that it's like once you get this on, it's just a simple, like a little 1/3 of a twist, and it locks it in place really tight. So you don't need any screwdrivers or Allen wrenches or anything like that on the field. You can do this all ahead of time before you get out to the field. The other option here is the little bit older style. Again, we have a flat bottom on this one right here. And these actually have little clips that screw into the bottom centering ring. And then you can just simply put your motor in, swivel these around, and then tighten them down with a screwdriver. But in this case, you do need to bring the screwdriver out to the field with you so you can tighten everything up. Another option is the threaded rod engine retainer. Wrong one. Threaded rod engine retainer, and that's this one right here. Again, we have a flat bottom, but this is a threaded rod, and it's about 4 inches long, so it goes pretty far up inside, and it's bonded in place along the engine mount tube. And then there's a little nut on here, and you just take that nut off, you take the washer off, you put your rocket motor inside, and then you just simply hand tighten it like this, and it will lock the motor in, preventing it from sliding out. These are nice and cheap. They're easy to install. Ideally, you want to install it when you're building the engine mount, but there is a way to install it afterwards, but it's a little bit trickier. The nice thing about the threaded rod engine retainer is that you can use it. It really comes in handy for when you're doing rockets that have clusters of rocket motors. So in this case, I have 2 engines and 1 threaded rod. So 1 screw will hold in both motors. And you can do this for multiple motor configurations. One other thing about the motor mount is a lot of people ask, what happens if you have a short motor mount and a long rocket motor, and the rocket motor sticks out the front of the tube? And that is okay. This is very common in rocketry, having a short tube back here. The only thing that you need to watch out for is you need some space in front of the rocket engine for your parachute. So sometimes there might be a bulkhead on the back of a coupler, or the back end of the nose cone might come all the way down here, and you do need some room in there for a parachute. So make sure you have room for the parachute. It is possible to wrap the parachute around the rocket motor tube itself. I've done that. It does work. Again, just make sure you're protecting the parachute from the heat of the ejection charge. Also on this one, I want to show you that this has the eye bolt right here for your shock cord anchor. Make sure that there's room. Make sure you use washers, first of all, because there's going to be a lot of stress on that centering ring. And those washers spread the force out. So when it's being tugged on the front end, there's a lot of bearing surface back here on the back to spread it out, so you're not pulling this eye bolt right out of the centering ring. Just make sure that there's room for the the washer, that it doesn't stick over the edge of the centering ring. As far as one of the things I want to talk about is rail buttons. On this rocket right here, you can see that the rail button, the front rail button, is also going through a tube coupler. So you can do it that way, but ideally we just want to go through, make it easy to install by just going through one layer of paper. This is the Apogee standard style of rail button. It's a 3-piece system. Let me see if I can, not that one, this one right here. We have a rail button itself, and then inside the rail button is a screw. And then on the inside of the tube is this part right here. We call that the weld nut. When you put these onto your rocket, what we want to do is to make sure to spread those rail buttons as far apart as possible. This front one, unfortunately, because of that tube coupler, we needed to move it back here, but this is as far back as I want to go. Ideally, I'd like it further forward. It just makes it more stable on the launch rod. The one in the back, we want as far back as possible because it just makes it easier to load the rocket engine onto the rail, because you got the back end of the rocket, you got the rail button that's right there, and you can look down at the rail and get it on. If that rail button is further forward, now you also have fins in the way, and so you're trying to keep the fins from whacking against the launch rail and scuffing things up and scuffing up your tube. So it just makes it easier when the back rail button is as far back as you can get it. On some other manufacturers, instead of using a 3-piece system like we do at Apogee, they use just a 2-piece system, and I'll demonstrate that here. And let me turn off this other rail button. Okay, so what they do is it's a rail button, and then inside of there is just a wood screw. Let me turn off the tube here so you can see it inside. But you need to get that wood screw into something solid, so you just can't stick it through the wall of the tube or it's going to just fall right out. So you have to try to get it right into the centering ring. And a lot of times you build the rocket and then you go to put that wood screw in and you miss. I would recommend, drilling a small pilot hole first so you can find that centering ring, so you know you're digging into the wood as much as possible. And you'll notice back here that on this particular case, the threads on the screw are actually sticking through the wood. That's okay. I would probably take some epoxy and smear it over the edge just to make it look nicer and make it just a little bit stronger. If you use this type of system on the front end, you'll have a problem. In this particular case, on the front rail button, that wood screw is going to stick very far into the tube, as you can see right here. And that can create a problem, especially with your parachute, because your parachute is going to be inside that tube as well. And that is a really good place for the parachute to snag on. The other issue here is that screw is not really digging into anything, so it's going to want to fall right out. So the solution for both of those is, first of all, put the screw through the tube, then pull it back out. And then what I want you to do is to cut it in half. So you're going to cut off the top of the wood screw and make it shorter so it's less likely to snag your parachute. But then also at the same time, I want you to put some epoxy clay on top of it to smooth it out, so that when the parachute runs over the top, it just slides over that protuberance inside and it doesn't get snagged on there. And then if you cut that screw pretty short, it's going to make that bump a lot smaller and make it even less likely to grab. A third option, instead of rail buttons, is a rail guide. I think I have a rail guide here somewhere. Right here. So a rail guide is basically a longer rail button, and they're mounted on the outside of the rocket, so nothing goes through the tube, which is really nice because you can put them on after you got your rocket assembled and you don't have to drill any holes in it. You can put them on while you're on the field itself. So, you know, if you forget to put a rail button on and you're at the launch, you can always take a rail button and slap it on there, glue it on with wood glue, super glue or epoxy. Just make sure that you're gluing to the surface of the paper or fiberglass and not to the paint, because paint is very weak. It's kind of like you're gluing that to a piece of chalk, and it's just going to snap right off because paint has no strength at all. So just take a knife and scrape through the paint and get down to the paper so that you get good bond to the rocket itself. The rail guides aren't as strong as rail buttons, but they do work. So don't be afraid to use them if you do need them. We use them here at Apogee all the time. They have a lot of advantages. So I think I've covered most of the things that I wanted to about the back end of the rocket, because that's the most important part of the rocket when you're designing a rocket. This has been a lot about philosophy of designing and also giving you the pluses and the minuses, the positives and the negatives of each of the different alternatives so that you can make a choice. But sometimes if you're confused, make sure you call us here at Apogee Rockets. We'll guide you through making that rocket, because our goal is to make sure that your rockets achieve the goal that you want for it, which is a nice straight vertical flight with a perfect deployment and an awesome recovery. Apogee is the place to buy your components. We are a one-stop shop for everything you need for designing rockets. We also have the motors and all the other components. We have a lot of kits. We have instructions. We have the RockSim software to help you design great rockets that are going to be nice and stable. So be sure to come to Apogee when you need your parts. My name is Tim Van Milligan. This has been the Apogee Rocketry Workshop. May the winds be light, may the skies be blue, and may all your rockets fly straight and true.